We're talking about detecting specific molecules in space that could indicate the presence of life.
You're talking about biosignatures, like finding a chemical fingerprint that says, hey, life might be here.
Exactly. And with the power of the James Webb Space Telescope, we're getting really good at sniffing out those potential biosignatures.
James Webb is such a game changer. I mean, analyzing the atmospheres of planets light years away, it's incredible.
It's mind-blowing. And one of the molecules that has scientists particularly intrigued is called dimethyl sulfide, or DMS for short.
DMS rings a bell, but refresh my memory.
You know that distinct salty, kind of sulfurous smell of the ocean?
Yeah, like a mix of seaweed and something else. Not exactly my favorite.
Well, that smell, believe it or not, often comes from DMS. On Earth, it's produced by tiny marine organisms.
So finding DMS on another planet could mean we found alien seaweed farms.
It would be a pretty strong hint that something interesting is happening on that planet.
That would be huge. Is that what we're looking at today? Did they find DMS somewhere?
That's where things take a fascinating turn. Get this. A brand new research paper we're diving into today found DMS in a comet.
Now that's unexpected. Comets are like cosmic ice balls, right? How could there be DMS on something like that?
And this new paper really throws a wrench into our assumptions about DMS as a surefire sign of life.
Hang on, back up a bit. If comets don't have life on them, how did the DMS get there?
Well, comets are full of ancient, what we call abiotic material. That means it's not derived from living things.
Okay, so not alien seaweed, got it.
Yeah.
But still, how does DMS just appear on a comet?
That's what makes this discovery so intriguing. This paper, Evidence for Abiotic Dimethyl Sulfide in Cometary Matter, challenges the idea that finding DMS automatically equals finding life.
So it could be a false positive, kind of like those motion sensor lights that turn on when a squirrel runs by.
In a way, yes. And it throws a bit of a curveball into our search for extraterrestrial life because we can't just assume that any DMS we find out there means we've found aliens.
Wow, this is already making me rethink everything I thought I knew about the search for life beyond Earth. So where did they find this abiotic DMS? Which comet are we talking about?
The comet in question is 67 Churyumov-Gerasimenko. It might ring a bell. It's the same comet that the European Space Agency's Rosetta mission visited back in 2014.
Rosetta. That was the mission that landed a spacecraft on a comet for the first time ever, right?
Exactly. A truly groundbreaking mission. And thankfully, Rosetta wasn't just there to take pretty pictures and had a very special instrument on board called Rosina.
Rosina. Why does that name sound familiar?
It stands for the Rosetta Orbiter Instrument for Ion and Neutral Analysis.
That's a mouthful. So what does Rosina do? What's its claim to fame?
Think of Rosina as Rosetta's incredibly powerful nose. It sniffs out the chemical makeup of the comet.
So it's like a cosmic breathalyzer for comet.
And one key part of Rosina is the DFMS, or Double Focusing Mass Spectrometer, which specifically analyzes the molecules in the comet's atmosphere, or what we call the coma.
I'm guessing that's how they found the DMS.
They found a strong signal for DMS in data collected by Rosina back in March of 2016.
Hold on, how can they be sure it's really DMS?
That's a great question, and it's where the real detective work comes in. They didn't just look at the mass of the molecules, they used a technique that analyzes the breakdown patterns of molecules, kind of like fingerprints. And the DMS fingerprint, as it turns out, is pretty unique.
Okay, that makes sense. But I'm betting it wasn't quite that simple, was it? There had to be a few more twists and turns in this cosmic mystery.
Okay, so we've got this cosmic puzzle on our hands. DMS, a potential sign of life, hanging out on a comet, which is about as non-living as it gets.
Right, it's like finding a penguin in the middle of the desert.
Exactly. So should we just scratch DMS off the list of things that might indicate life on other planets?
Well, I wouldn't be so quick to dismiss it entirely. Finding DMS on a comet doesn't necessarily mean it's never a sign of life. It just means it's not a foolproof indicator in isolation. When we're talking about the vastness of space and the mind-boggling diversity of potential life out there, we have to consider all the evidence.
Makes sense. So how does this discovery change how we approach the search for extraterrestrial life?
It really highlights the importance of looking for multiple lines of evidence, not just relying on a single molecule like DMS.
Like what else would we be looking for?
Well, the presence of other gases, for example, or the planet's temperature and overall environment.
Okay, so we need to look at the bigger picture, not just focus on one single thing.
Exactly. And even a planet's history could be important in this kind of search.
A planet's history? What do you mean?
Well, think about it. What if, billions of years ago, A comet carrying DMS, just like 67P, crashed into a young planet.
Oh, interesting. You're saying some of that DMS could have survived the impact and ended up in the planet's atmosphere?
It's a possibility. And that's why it's so important to be cautious and thorough. We can't jump to conclusions based on a single piece of evidence, like finding a trace amount of one molecule. This discovery is a good reminder of how much we still don't know about space and the origins of life itself.
It's humbling, isn't it? We like to think we've got it all figured out, but then the universe throws us a curveball like this.
And that's what's so exciting about science. It's not just about finding definitive answers. It's about expanding our understanding and asking bigger, bolder questions.
So, what are some of the big questions this discovery raises for you? What has scientists buzzing right now?
For me, the biggest question is, if DMS isn't a slam dunk biosignature.
What other molecules might indicate life? Ones we haven't even discovered yet.
Exactly. And then there's the question of how common this abiotic DMS really is. If we find it in other comets, or maybe even in interstellar clouds, it could change our whole understanding of how life might arise in the universe. This DMS mystery has thrown a wrench into our old assumptions and pushed us to think more creatively about the search for life beyond Earth.
Okay, so we've established that we can't just rely on DMS alone. But I'm curious, how did the researchers actually measure those DMS levels on Comet 67P? Didn't the paper compare it to another molecule, methanol or something?
You've got a great memory. They did compare the abundance of DMS to methanol, and that's where things get even more interesting. They found that the abundance of DMS on Comet 67P remained relatively stable over time, similar to the levels of methanol.
Stable. You mean it wasn't just appearing and disappearing randomly?
Exactly. They looked at data from different points in the comet's orbit, months apart, and the ratios of DMS to methanol were strikingly consistent. And that's why the researchers think both DMS and methanol might be sublimating, going directly from a solid state to a gas from a similar layer within the comet.
Fascinating. So we've got these two molecules both hanging out together in this ancient comet, both found in interstellar clouds. It's almost poetic, isn't it? Like the universe is dropping hints about the ingredients of life.
And that's what makes this discovery so profound. It's not just about DMS or comets, it's about challenging our assumptions and pushing us to explore new possibilities in the search for life beyond Earth.
Until next time, keep looking up at the stars and never stop questioning the universe around us.